Okay, hello. My hair is still a mess, but what isn't a mess is the fact that we have technically an exam tomorrow. More of a assessment because it's a very specific exam, going over purely all of the statistic stuff. So, what I have is my book, and literally all we're doing is this is all of the stats exam questions that they've ever asked. We're just gonna go through them, plot some stuff on here based on what we can pick up from the exam. So not really doing too much, just gonna be doing a tad bit of revision. So the thing I notice is a lot of these stats questions are very formatic. They're literally asked in the exact same way. First one here asks us to state the null hypothesis and a statistical test to determine whether the difference between the mean between two different conditions is significant. Right. Number one, what the hell is the null hypothesis versus the alternate hypothesis? To put it plainly, the hypothesis is, I'm pretty sure, it's your IV on your DV. So if we very quickly do this, just for reference, the independent variable is the thing we adjust. Meanwhile, the dependent variable is the thing we measure. So for example, if we're testing, I don't know, concentration of fertilizer on plants' growth rate. So an alternate hypothesis might be that there will be a significant... In fact, hold on. How do I always fuck up the wording of these. There will be a significant difference of plant growth rate based on concentration of fertilizer. That could work. There's better ways to word it that I can't run across my head without writing it down. The concentration of fertilizer will have a significant difference on plant growth rate. That would be an example of an alternate hypothesis. It's literally saying that the variable that you're changing will have an effect on this. And contrarily, I don't know if that's a word, on the contrary, the null hypothesis is saying it will not. So it's really easy to know what they mean, it's just difficult to phrase it in an appropriate way. That's why practice with these questions is very much recommended. That's what I'll be doing tonight anyways. So we know what the null and alternate, I don't know what you call it, the null and alternate hypothesis. We know what they are. So it's asking us, name the test needed to determine whether the difference between mean is significant. So I'm pretty sure we do full, proper, I guess, standard deviation too. But we have the paired t-test, the unpaired t-test, Spearman's rank, or I guess it's Spearman's correlation coefficient. Sure, you can get away with saying Spearman's rank though, I don't know. And then the I don't know how you pronounce this. Is it the chi-squared? I don't know. I don't know how you pronounce that, to be completely honest. But these are the five main ones. I don't know whether they would ask you much about this. And actually, I haven't seen any exam questions where they want the specific name here, but we'll do it anyways. So the differences between all of these is, first and foremost, t-tests allow you to determine the difference Well, if the difference between two means is significant. So overall, these allow you to determine if difference between two means is significant. And just for the sake of this video and this stream, sorry, I'll be writing significant as sig, and I'll be writing difference as diff. So if you're looking at this and you're confused as to what I'm writing, I'm just abbreviating stuff to make it easier, because I'm lazy. So it's to determine if the difference between two means is significant. Standard deviation, I guess I could draw a little example here. I'm going to draw the bar chart very spread out so it looks nicer on the eye. You shouldn't draw it like that though. It's like these error graphs, basically. And the whole gimmick with standard deviation, it allows you to determine if the data is likely to be significantly different. It doesn't tell you. You have to remember that. It only tells you if it's likely. So, for example, if the data overlaps, which it's doing here, the error bars are overlapping, the standard deviations are overlapping, that means that it's likely to be significantly different. This one isn't overlapping, which means it is likely to be significantly different. So if it overlaps, it means it's not. If it doesn't overlap, it means it probably is. Just for reference, it's always plus and minus when you're drawing them. So if the standard deviation is 4, the mean is 10, you would obviously plot it so like 10's there. I don't know, what scale are we going to use? Like 6 to... I don't know. I have fumbled this completely. But you would always do, obviously, 4 up and then 4 down as well. That's how you would draw an error bar. You wouldn't just do 2 there, 2 there. So, that's standard deviation. It tells you... It also gives you an index... Oh god, what have you done? Also, I'm going to have to turn off chat there because it blocks the board. Chat will still appear here. What have you done? Anyways, a big important thing about standard deviation too, very important, is this whole idea of reliability with data. How reliable is the data? If a standard if the mean is 10 and the standard deviation is 1, that means that the data is likely to be within, 1 of the mean. Or within 1 standard deviation of the mean. It'll be 11 or 9. Meanwhile, if the data is 10 and the standard deviation is 8, your data is pretty unlikely because that's a range from anywhere to 2 all the way to 18. So standard deviation, okay, there's no need for that. Standard deviation is very important for that. And I think it's probably the easiest one to get a grip of. It's difficult to calculate, actually. I don't recall the exact method of calculation. If you gave me a table, I could probably do it. But on calculators, those white ones that I don't have access to, you can do standard deviation just on a calculator. Which is really overpowered, and that's why I keep meaning to ask Miss Glenn if she has a spare. Now back onto the t-tests. The paired is... Okay, I'll write some examples. Paired t-tests are if it's the same group... The same group does... both conditions. Meanwhile, an unpaired is if it's 2 different groups doing, I guess, one data each. Well, one condition each. So let me try and word this as best I can. Paired, well, it's easy to know which one's which. Paired is same group, both conditions. Unpaired is different groups, different conditions. So let's do an example. Let's go back to that fertilizer thing I was on about earlier. A paired one would be if we have group A, and only group A. They first do a concentration of 10, and then they do a concentration of 20. Meanwhile, an unpaired one would be group A does 10, group B does 20. Now, it would be important to do this for a lot of reasons. I think obviously if you have two different groups, it's a larger sample size, whatever. But the table should look the same on completion, I'm pretty sure. Let's try and map this out. Let's say there's 5 subjects. Doing test A, then test B. Yeah. I guess that would work. Just for that one, it would be there. That one, it would be there. That one, it would be this one there. Okay. So it's different. It's different depending on what you do. For the paired, you would have to put just the number. No, it is the same. Okay. Again, it's a tad confusing, but I hope that summarizes it. For the paired, it's A. For unpaired, it's A and B. I hope that makes sense. In fact, I'll even write that there. So, the is it the chi squared? The chi, I think chi squared rings a bell. Let me see if I can recall which one this is. Oh, and before we even get into that, we need to know how to write a good conclusion. It's very simple. There's kind of 3 main bullet points you have to take to get full marks. Oh, where have I put my pen? Okay, bullet point 1 is saying that the value, we'll just call it n, is greater than or less than the critical value. And critical value can be determined once you've actually done the test. You find it on a table. It's always n minus 1 to get the degree of freedom. So the degree of freedom is n minus 1. So if you had 10 subjects or 10 samples, it would be 9. You'd follow it along, look at the actual percentage you want, the degree of accuracy. So in a lot of science experiments, it would be 1%. But I think unless you're told, you usually go with 5%. So you would line it up on the table, on both ways, to get your critical value. So you're going to say that the value, the end result, is greater than or less than the critical value. Then you can accept or reject the hypothesis. And you have to specify which one. Do you accept the null hypothesis? Do you reject the alternative? Just anything to get a mark. And then finally, you need to justify why. So, for example, the value 0.6 obtained from the unpaired t-test is greater than the critical value of 0.5 at a, I forget what you call it, at a percentage of 5%. What do you call it? One sec. Oh, and before I forget, one more thing. For determining degrees of accuracy, that is just n minus 1. That is n minus 1 plus n minus 1. Because it's two separate groups. That, I feel like, could make people lose a shit ton of marks. That's evil. So, for unpaired, it's two groups, which means doing it twice. I think that's easy enough to remember. Two groups doing n minus 1 twice. Anyways, you would accept or reject. So let's say we reject the null hypothesis. Therefore, the concentration of fertilizer would not have an effect on plant growth. Significant effect. Anyways, chi-squared. This is if there's a significant difference between observed data and expected data. So, is there a difference between, I'll just draw like observed and expected. And I'm pretty sure this is only for frequency data. Yeah. So, for example, how many frogs are in a pond? Pond A, you would expect results to be about 50, pond B, 20. In actuality, there's more in B. I don't know. This one requires you to calculate the totals. It's actually kind of complicated, to be honest. You find the raw totals. You kind of split it up. Add it up. Yeah. And then finally, Spearman's rank coefficient correlation is probably the easiest one. This literally just tells us, like, is this significant? You know, that would obviously be like 0.82, for example. So, let's quickly recap. Standard deviation allows you to figure out how reliable... Oh, I'm just going to move that. There we go. Standard deviation allows you to figure out how reliable the data is. A bigger standard deviation means it's less reliable. When plotting, make sure you go plus and minus. If the error bars overlap, it means that or if the standard deviations overlap, it means there is likely to be no significant difference between the data. If they don't overlap, it means there probably is a significant difference. The paired t-test allows you to determine whether the mean is significantly different between two sets of data, but these two sets of data are from the same group. So it's the same group doing two different conditions. One after the other. To determine the degree of freedom for this, it's n-1. On unpaired, one group does one condition, the other group does another condition. Therefore, it's n-1 plus n-1. The chi-squared is just for frequency data, and that's whether the observed data is significantly different to the expected data. If there's a difference between. So, let's start looking at some exam questions then. And I'm only going to rush through these, so. The student noticed there was a difference in shell height between two populations of snails. He wanted to investigate if the difference was significant. Give a suitable null hypothesis to use in the investigation and name a test. So what test will we use? Well, we're wanting to determine if the difference between two groups is significantly different. So I'm going to say t-test. I feel like that's the only reasonable one there. Maybe correlation coefficient? I feel like it has to be t-test. There better be a mark scheme here, or I'm going to have to... Oh, there is a mark scheme. Okay. A null hypothesis usually takes a format of there is no significant difference between the samples being studied. So that's what the examiners say a null hypothesis should be written as. There is no difference between. The t-test is appropriate. Standard deviation is not a statistical test. Yeah, I think that's obvious. It's a form of... There's two types. There's two possible types of data. One is with the mean, median, and mode. One is with standard deviation, range, and something else that I've forgotten about. This is just a form of expressing data. These are all the statistical tests. And these two are exactly the same. So in an exam, unless you're asked specifically, it's a t-test, not a, But yeah, that's interesting. There is no difference between the samples, yep. It is pleasing that many students appreciate that when comparing means, the t-test is most appropriate. So yeah, it was on about comparing means. Question 2. Let's check the mark scheme. There is no significant difference between the mean, height... Okay, hold on. So you can write a null hypothesis as just there is no significant difference between x. Wow, okay, that clarifies a lot. See, what my answer was there is no significant difference between the heights in group N and group, I could have literally just said there is no significant difference between heights in the populations. And yes, it's a t-test. T-test allows you to compare two means. Oh, and the p-value, before I forget, holy shit. This is really important. The p-value tells you if something's significant. If it's 0.05 or less, that means it likely is. If it isn't, it means it likely isn't. There you go. Calm. So if you see p-value and you're sat thinking, what the fuck does that mean? What's a p-value? I thought it was a t-test. P-value, that is significant, okay? Read about it. I forgot about that too, I can't lie. If you're given some data and asked to come up with a hypothesis, you should use the data. So if it's on about red, green, and what is it? Red, green, and blue cones being stimulated, you should absolutely clarify that You know, you should say, the red and blue are stimulated, green are not. Final one or two things just to check. You can compare the DNA base sequences and names of proteins or sequences of amino acids if you want to determine the differences between species. Okay, well, I think we're fine. I think that tomorrow we should be okay. I'm holding out for like 60%. But the thing is, right, guys, biology is hard, yeah? Biology is difficult. Don't get me wrong, okay? I personally last year thought that the AS exam was horrible. I hated it, to be completely honest. I was sat thinking, I've absolutely failed this. The questions were really bad, a lot of really difficult ones, and I ended up doing quite well. A lot of people didn't because of the grade boundaries, which shot up. So let me try and plant some reassuringness very quickly. If you want to pass biology, realistically, most universities want a biology at a C level or a B level. And from what I can recall, I think a B is about 50%. I think a C is going to be about 45%. I think an A is going to be about 60. I think A star's like 70, 75. So realistically, if you can hold out for a 60%, then good for you. That's all you need to pass and get a great grade, okay? 60%. And in most exams, only 10% of those marks are to do with math. That means it's highly likely that you will only get asked about one tiny thing from this huge topic. Look, 3 marks right here, 1, 2, 3, for saying this value is greater or bigger than, we can accept this because 3 marks, 3 marks. P-value, probably a mark. Saying use a t-test, I've found that in a lot of exams, it's 1 or 2 marks. Talking about this, maybe 1 or 2 marks. You can pick up dozens of marks in the paper just for tiny bits of knowledge. It's highly unlikely that you will need to do math like that or math like that. Probably the most difficult thing you'll do is Spearman's rank. So, good luck with that tomorrow, everybody. Because for certain, we will obviously need it. But yeah, good luck, everyone. Hope this stream was of some help. And yeah, that's, as far as I can recall, everything we need to know about statistical testing. Standard deviation. Paired is A, unpaired is AB. That'll already help me a lot in the exam to remember. Chi-squared is for frequency. Spearman's rank. We've done that in GCSE. It's easy. So good luck, everyone. Stay safe. Take care. Thank you.